Today's lesson is on solving equations. We've been dealing with expressions and we're moving on to equations, which means an equal sign. And it means that one side of an equation is equal to the other side. So what I have here is just a true or false question. If you have this equation, is it true that x equals 4 or is it false? And all that means is you're going to plug in 4 for x and check if it's true or false. So 2 times 4 plus 8, we just want to see, does that equal 16? Well, 2 times 4 is 8, and 8 plus 8 is 16. So 16 equals 16, therefore this is a true statement. Alright, so here I have a different equation. 32 divided by x plus 7 equals 15. And we're basically giving different values of x. Maybe x equals 2, 3, or 4. And for each one of those numbers, we're going to plug in for x and decide is when you plug in that number, do you get a true statement or a false statement? So let's first rewrite the equation where we plug in 2 for x. 32 divided by 2 plus 7, does that equal 15? Well, 32 divided by 2 is 16, and 16 plus 7, well, that does not equal 15, so this is false. Let's try number 3, plugging in 3 for x. So 32 divided by 3 plus 7, does that equal 15? Well, I can tell right away, 32 divided by 3, we're going to get a decimal, and adding 7, there's no way that this will be equal to 15. So this is also a false statement. And then the last one, let's check. 32 divided by 4 plus 7. 32 divided by 4 is 8, and 8 plus 7 does equal 15. So this is a true statement because both sides represent the same number. Here's an example of an equation in which we want to solve for x, and since x is all by itself on one side of that equal sign, all we have to do is just simplify what's on the right side. So let's simplify the numerator first. 3 squared is 9, and then 9 times 2 is 18. 18 plus 4, and then in the denominator 4 squared is 16, and 16 minus 5. So keep simplifying. 18 plus 4 is 22, and 16 minus 5 is 11, and 22 divided by 11 is 2. So in this case x equals 2. Okay, now in this example, x is kind of mixed in with some other numbers. It's not by itself. So let's simplify everything that we can so that we can determine what value of x would create a true statement. 4 squared is 16, so 20 minus 16 plus x equals 30. And then 20 minus 16 is 4, so 4 plus x equals 30. We just now need to determine what value of x makes a true statement. What value of x, when you add it to 4, gives you 30? And that is 26. X has to equal 26 to create a true statement right here. And you can always check your answer by plugging 26 back into the original. And do 20 minus 16 plus 26 to test if you get 30. So here is another example. Let's simplify what we have. I draw a line at my equal sign just to try to keep things separated. On the left side I have 2x plus 1. I can't simplify that anymore, so I'm going to leave it as just 2x plus 1. equals, and then x plus, we have 10 minus 6, so x plus 4. So now this is kind of tricky because we have x on both sides of the equal sign, but x can only have one value. So what value of x, when you multiply it by 2 and add 1, do you get the same thing when you add 4? So why don't you pause the video, stop, and think about it for a second. See if you can figure it out. Sometimes it helps to guess and check. So maybe you guess 2. 2 times 2 plus 1 gives me 5, and 2 plus 4 gives me 6. So 2 doesn't work because I don't get the same thing on both sides. Let's try 3. 2 times 3 plus 1 is 7, and 3 plus 4 is 7. So when I plugged in 3 on both sides of my equal sign, I get the same number, that 7 equals 7. So therefore, to create a true statement, x has to equal 3. And once again, remember, after you get your answer, plug it back into the original to see if it works. 2 times 3 is 6 plus 1 is 7. And then 3 plus, well, 10 minus 6 is 4. 3 plus 4 is 7. So it works. Now we're going to do a few examples of equations that I consider special cases. And I consider them special cases because instead of getting a value for x, you will determine if there is no possible solution for x that will create a true statement, or are there infinite solutions, which means every number, no matter what number, when you plug it in for x, it will always create a true statement. So if we look at this first equation, I like to separate that equal sign and simplify anything that we can. So let's start. We have 2 to the third power, which is 8, and 8 plus 4 is 12. So 12 plus x equals 8 plus x. Now I'm just going to rewrite it the other way, put x in front, just so we can visualize. X plus 12 equals x plus 8. What value of x would make this true? Let's see. If you plug in a number, this number has to be the same on both sides. On one side you add 12, but on the other you add 8. Could it ever be true? I'm just going to throw out one example. Let's say x equals 2. So you have 2 on both sides. One side you add 12, the other side you add 8. You can never start with the same number, add different numbers, and ever get them to be equal. So in this case, there would be no possible solution. There's no value of x that will ever make this statement true. Here's our second example of the special cases. And there's a lot going on, but always just start with simplifying. Simplify what you can on each side. So 3 times 2 is 6. So I have 6y plus 7 equals 6y plus 21 divided by 3 is 7. So I have 6y plus 7 equals 6y plus 7. What value of y would make a true statement? Well, let's say you plug in the number 5. 6 times 5 plus 7 will give you 37, and then 6 times 5 plus 7 will give you 37. Give you another number. 6 times 2 plus 7, let's see, 12 plus 7 is 19. 6 times 2 plus 7 is 19. And obviously, as you can see, if you have the same thing on both sides of this equal sign, it doesn't matter what number you plug in for y, you will always create a true statement. So there are an infinite number of solutions to this equation. Here is the last example, and I want you to write it down, pause the video, and try it on your own. See what answer you get. So after simplifying, you should get no solution, because never, if you have 4w and 4w, the same thing on both sides of that equal sign, and then on one side you subtract 3, but the other side you add 3, would you ever get the same thing on both sides? So, not possible. In this case, there's no solution for the value of w. So, there's the lesson on solving equations. You are just figuring out what number would go into the variable to create a true statement. Good luck with the lesson.